Hi, everyone, and welcome. I'm your host, Henry Clavo, CEO and founder of Orlando Insight Group. Each episode, we dive into real conversations with technology leaders, innovators, and experts who are shaping the future of IT data and cybersecurity. Our goal is simple to give you a practical insights, real world strategies, and expert perspective that you can use to drive smarter decisions and strong results for your business. So, thank you for being here tonight, and let's get started. I wanted to introduce Orville Daley, first introduced to robotics in 2021 after being recruited to his high school robotics team. Amazing. Quickly found his passion for STEM. By 2022, he was representing Jamaica on the global stage as a lead programmer for that year's first global team. 2 years later, in 2024, Orville returned to First Global, not as a student, but as a youngest member of the National Robotics Coaching Team, where he's now focused on technical writing and helping students members strengthen their public speaking skills. Driven by deep commitment to STEM and equity across Jamaica, Orville continues to inspire and empower the next generation of innovators. He has also completed two internships at Microsoft during his undergraduate studies, where he's worked on cutting edge projects in AI agents and Windows development. Um, well, we could get started. It's a funny story, like how we met. Like we were, I was just taking the light rail in Seattle, and then there where you are. I just said, hey, how you doing?
Yeah,
Is that a notebook?
yeah. I had my backpack with my three computers at the time. Had to take out
Yeah.
one and then take out the other one because I needed to charge my phone. And then you were like mentioning that you used to carry all those different laptops to school, to work as well. So I was like,
Yeah.
oh, okay. So that's when I realized that you were involved in the IT world. You know?
Yeah. Oh man, don't remind me. It's been a long while, but it was a great conversation. Great to meet you and your team at Microsoft, and the good work you're doing, especially during the demo day, which was amazing, by the way.
Thank you.
But just to get started from um, so you have achieved so much already, from first robotics champion to now a Microsoft intern in the past. What first sparked your passion for robotics and AI at Orville?
So originally, I want to become a doctor.
Mhm.
Growing up, because that's kind of what you're kind of somewhat told to want to be. You know, someone like a doctor, maybe sometimes an engineer.
Mhm.
Eventually, I realized that I do like computer stuff. Nothing specific. Just like, oh, I really like watching YouTube videos of people coding. Didn't really learn anything particular about it. But then when I went to high school in 2016, I realized that I wanted to be in robotics. And so I originally tried to be in robotics, but it was an issue I couldn't get to actually join because I was
Right.
busy with other things at the time. And then but I was still being involved in like coding in general and stuff like that. And
Mhm.
then in around 2020 slash 2021, I
Mhm.
did a competition, a coding competition, uh, on national level, and I won. And so my school realized that I won that award and actually recruited me for the robotics program. So that's
Wow.
when I first got into robotics itself, but I was involved in STEM beforehand. And so when I was involved in robotics for some time that first year, I was like, this is really cool. I really like doing this kind of thing. It's not just about the coding aspect, because as I moved further along robotics, I actually coded a lot less and was more involved in managing people who code, or helping people understand different things.
Mm.
So then when I realized that I really like robotics, I stayed there. And after competing on a global level and coming back to Jamaica, I made it I basically made it my mission to
Mm.
help other people be involved in that. So I was
Mm.
actually working with the organization here in Jamaica, where, for example, next week Saturday, I'll be helping them get more rural schools involved in robotics.
Uh,
So as I go on, I realize that I see robotics as a way to get more people involved in STEM. And for AI specifically, it was that when I came to Microsoft, I came and I told them pretty plainly, I'm not really used to AI. I'm not really used to this kind of stuff. Like, my background is in robotics.
mm.
Their response was pretty much, yeah, you learn the stuff as you go along. You'll understand as it comes. And I
Yeah.
was like, okay, like that has no problem with me. So that's when I learned about Windows development and AI agents, and a lot of it was just about learning, which is the same thing I did in robotics. So then
Mm.
I really take a lot of things that I've done as just learning new ways of doing things.
Mm. It's amazing. Like, I wish I could go to the interview and say, "Oh, this is my approach," and then I would just the door was shut in front of me. But That's cool, man. You just went directly. You told Microsoft this is what I bring to the table, and they accepted you. Good for you, then.
Thank you.
Um, as a first generation university student, what how has that shaped your drive to approach to learning?
Uh, I have four siblings, and both my parents.
Mm,
And so the two of my siblings older than me, they have gone to university before. However,
mm,
my parents didn't even finish high school, and
mm,
so it's a big part of my upbringing to try to be better than the previous generation, as in try to do new things, ensure that I'm taking these things, all the resources I have into consideration.
mm,
And so, as for example, my sisters that went to university, they helped me with my schoolwork. I'm now helping my brother with his schoolwork to ensure
mm.
that they learn as they the students, the kids below me,
Right.
learn as they come up. But then the question begs: is it supposed to be kept in the family, or like, am I supposed to only do that there? And so I realized that there's a lot of other people who have parents who don't go to university, or they don't think that they can go to university. So I actually tried my best to not allow to not allow those kind of factors to affect them as much by simply
Mm,
doing things. For example, I'm helping some students write their essays to apply for scholarships here in Jamaica.
mm,
Um, Anytime I see a particular uh, uh, a particular initiative or application that a student can do,
mm,
I just send it out immediately. Like, hey, this is an opportunity that's available to you. You should definitely think about doing it, all that kind of stuff.
mm,
Because oftentimes the difference between being a first generation student and pretty much anything else
mm,
is not necessarily ability,
mm,
but the access to opportunities.
mm.
So I think that the moment that I'm able to provide opportunities to others, they will succeed very easily. Because
Wow.
being a first generation student simply means that you have a lot to offer, a lot of perspectives to give. And
Mm,
so it's important that as you're doing anything like that, you just ensure that you're fighting to get other people to the table that you're sitting at.
right. So bringing down not so you're giving back, trying to give that opportunity because you had that opportunity, especially now your experience, 2 summers in Microsoft. You just want to see other people succeed. That's amazing.
Yeah.
You know, uh, you've completed 2 software engineering internships at Microsoft. What were the most exciting projects or moments from those experiences at Orville?
Okay, so uh I think the first internship was a lot of learning about culture, what it
Mm,
is at Microsoft. The
mm,
project was pretty okay. It was just an AI project, my first time doing anything like that. So my manager made it very clear that we were trying to just develop skills, stuff like that. My second internship was quite different.
mm,
I was still learning, but this time my manager from is the same manager from my previous year, but he realized that I really like to learn. And so when he gave me my project, it was the cutting edge stuff. So I arrived in June, and
mm,
earlier in the year, Anthropic released MCP. And
mm,
so it was basically my job to learn all that kind of stuff for create a framework for other people to use. So then a lot of the things that I was working on simply didn't exist or didn't exist in terms of documentation. And
mm.
he knew that I loved experimenting and figuring things out on my own. For example, one of the a part of the project involved me determining different prompt engineering techniques, which
Right,
is pretty simple. But one part of it included train. I was thinking of, oh, I could improve the small language model by involving uh, chain of thought. But before
right,
I even do something like that, I actually read a paper. I read a research paper that was saying chain of thought is like really good for large language models. But the moment that they're small language models, it literally wastes tokens, and sometimes the responses are just not up to par, even though you're wasting all these tokens.
right.
So a lot of my most memorable moments are whenever I would want to do something, read probably 2 research papers,
Mm,
uh, came with a conclusion, bring it to my manager, and he's like, "Yeah, that makes sense." And he usually like understands that most of my work is is explorative. So it's
mm,
me figuring something out, not necessarily that it will work, but just writing it down. So for example, when I left, I had this big documentation left for someone else
mm.
to go through and understand what I was doing. Because again, a lot of the things I was doing was cutting edge, like LoRA adapters. There's actually no documentation
No.
about how to do 5 silicon LoRA adapters. So just that, things like that, was what really made Microsoft experience memorable for me.
Yeah, yeah. Like you're pretty much a pioneer and taking the charge to make Microsoft uh, give them this opportunity to explore. How did that feel? Like you have no goalposts, you have no direction. How do you manage that project while not staying stuck or moving in directions that doesn't lead to your results?
The first thing is that when I went with a manager, the first meeting, we determined what the plan is.
Mm,
There's no product manager slash program manager, but
mm,
except him himself. And so he came with a proposal basically of a starter kit that would have these particular features, and it should be proposed to the OEM partners.
mm,
He has all these different features, but he does not necessarily know how these features would connect or how they would be implemented. And
mm,
so the we created a timeline to some degree, but the
mm,
timeline only had a start and a theoretical end, meaning this is the end result, the start is here, and we started filling in the blanks in between. So, for example, in the early start region, I need to learn MCP, I need to learn about small language models. We know things that need to be learned, and for example, near to the end, maybe like out of the 12 weeks, near week 7, we need to have a prototype of these particular features. And
mm,
then as we do that, we realize that we can fill in a timeline. Timeline might
mm,
not be super complete, but that way we can keep on track to
mm,
not completely derail a 12-week internship, because that is a really short time.
mm,
So then that's how it really worked in management of the particular things. And then so I also gave him updates every single day, because that way I know what I'm doing and he knows what I'm doing. Because
right.
again, if it's so much exploration is involved, talking to people, talking to different teams, getting documentation from teams that they can non-existent documentation from teams, means that whenever I get new information, I need to update him on that, so that he knows that I'm keeping on time with my entire project.
Mm. Got it. Oh, that makes sense. Yeah, it's like a partnership. You're a team. You have to make sure that uh, you're both working together, so he's successful and you're
Yeah.
successful from that intern program.
To add
Uh,
to that, actually, the my peers that I was working with as well, they
yeah.
would also be very involved in my project. So whenever I made a big milestone in terms of like a particular feature was complete, I would have my senior peer,
Mhm.
who is a software engineer, would review the code and be like, okay, this is how you decide to do the feature. To some degree, he wouldn't know how the feature should work either, but
Mm,
but because of his experience, he'd know how it would look or behave. So he wouldn't know how to build it like all this on top of his head, because again, it's new. But he's like, oh, this is your approach to doing it. Okay, that's a bit unusual from like industry standards, or oh, you could take into consideration this new feature that also came out recently, and you should incorporate that. And then
mm,
whenever that was passed on, I added to the timeline, but I never. There's always more steps. So like for example, only there's like week 12. There's
mm,
like weeks after it as well, but those things are for the person who comes after me, so that
mm,
they know, hey, this is your direction that you should be taking as you
mm.
continue.
Right. So you come up with the innovative ideas, and then you have structure like a software lead to help you guide you, so you don't get stuck on details or processes. So that's
Yes.
amazing. What was it like to developing an AI agentic AI starter kit for Copilot plus PCs, researching small language models like Phi Silica?
So originally, I was working with Phi 3 Mini,
Mm-hmm.
which is not a small language model, but it's relatively small, but it's not a small language model.
Mm-hmm.
Uh, it's not classified as that, I believe. But regardless, it was really fun to work with that, because then I learned about retrieval augmented generation and fine tuning and all that kind of stuff. And then my job was to figure out how does that translate to Phi Silica, the big new thing that they're trying to push
Mm-hmm.
for all co-purpose PCs. First
Mm-hmm.
of all, I thought it was super cool, because the entire announcement for co-purpose PCs, I was actually watching Microsoft build when they did that, and I thought
Right.
that was super cool. And then somehow getting the chance to work on it at your internship, kind of feels like destiny like.
Mm-hmm.
So then when that happened, I was like, okay, this is cool. And then for Silica, I got to talk with all sorts of different teams that are involved in it. To be honest, Silica is quite experimental. There's like still lots of bugs to figure out. But it was really fun to work with all that stuff because I am simply creating or building on things that almost don't exist. In fact, during every week of my timeline, on I think it was Wednesday or Thursday, I would need to figure out if something broke because Physical would be updating so often that the quality would either diminish or improve based on my prompt. So I
Right.
was always doing these tests every week to see like, hey, did the update of Physical break on my project? Because it could. And then similarly, because I was in C# in Visual Studio, a lot of different things there as well was also just breaking. Everything's experimental. The MCP extension, experimental. But that is exciting because I'm like, oh, okay, this is a new feature. I'm working with things. I'm reading about these new things. I'm getting I'm getting the level of introduction that a lot of people at my age would not get from these kind of experiences. And
Yeah.
then when the entire project was complete, I got the chance to present it to different OEM partners. So I was actually the person presenting. So it wasn't my team saying like, "Oh, we'll present it for you," after you're gone. No, it's I got the chance to present in front of two OEM partners, and then their response was basically they like it. They like the idea that all this can be done on the device, no internet access needed. Um, there's no need for like super large language models to call functions. Small language models are not able to do it. All that kind of stuff. So whenever I was working with it, it was just really cool in general to work with something super brand new and trying to bring that to the table.
Got it. Got it. It's amazing, Orville. So, when working on that, what were the biggest technical and creative challenges you faced while working on AI agents, RAG, and the RAG methodologies? Obviously, there's so many, but I guess you could zero in one that gave you some hard times.
Uh, so one of the things is that I wanted Silica to call tools from MCP, and
Mm,
so the way that a lot of large language models do that is through JSON or
right.
they're built in. Physical is not built in, so my job was to make it respond in a particular manner. But all the training for Silica beforehand, so the pre-training, is in question and answer. So
Mm,
if I told it, hey, here are some tools, I want you to call them, it would say something like, your question was great, da 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 da, all these different like talking beforehand, and be like, so I want to call this tool with these particular parameters, but that's a full paragraph,
mm,
which is hard to translate into a tool call.
mm.
So about 3 weeks of my internship was literally just me figuring out how to get Silica to respond with only a tool call, no extra talking involved, and being very standard. For
Mm,
example, if you ask it to do something in JSON, it might do it in JSON one way today, and then tomorrow it does it in JSON, but like in a different manner.
mm,
So it's very similar, but I need it to be super structured so I could parse that through code
mm.
and just call a tool appropriately. So my biggest challenge was figuring out how to make a conversational AI work how I expected it to work.
Got it. So I understand that large language model has three things. Like they have the system instructions or the system prompt, the primary prompt, and the retrieval augmentation generation. Um, did Five Silica had a system prompt, or you had to do it a different way?
It does have a system prompt. However, if you put it in a system prompt, it doesn't respond exactly. So, if, for
Mhm.
example, if I tell it, "Hey, respond in JSON," it would still maybe not respond appropriately, and so that's
Mm,
why the LoRa adapter was for. It's
mm,
basically giving it examples of questions and the tools,
mm,
and then using Azure to create a LoRa adapter, and
mhm,
then I can just add that LoRa adapter to the Silica model, and it just responds the correct way every time because it sees all these different examples. In the system prompt, you might have maybe like only 3 examples, but with LoRa adapters, you can have maybe 1,000 examples, and all
mm.
that is really small because instead of training an entire model over, you only have something that I think it was like a couple megabytes
Right.
to have that LoRa adapter,
Yeah.
and in theory it learned instead of just learning examples, it learned patterns. So for
Mm,
example, while the examples that were in the training data set
mhm,
were of a particular tool, we were able to get Silica to respond given any tool. So just telling it in the user prompt, for example, that these are some tools that are related. What tools do you want to call? And even to add to that, because PySilica is a small language model with a limited context window, it was important that we found a way to tell it the tools without telling it all the tools, because some MCP servers have like 300 tools. We can't tell it that there are 300 tools. So we actually use a semantic search API to remove a lot of the tools from the 300 list. So maybe only the most related 5 tools, and tell PySilica, hey, these are the tools that you know. So because that PySilica could respond in a particular manner, accurately every time, and it did not depend on which MCP server it was connected to. It didn't matter. It didn't have a limit to the amount of tools, because we use semantic search to limit the number of tools it sees at one time.
Interesting. And for our audience who might be technical and non-technical, what is the LoRa adapters, and how does it connect to the LLM model, and what process you use for it to detect these patterns?
So the simplest way of explaining a LoRa adapter is, imagine you have an AI that is good at everything. So that would be like ChatGPT or no one of those. But then the problem is that sometimes you want that AI to be very specific at one thing. So you're telling, hey, AI, you should actually not be very good at everything. Be super good at answering math questions, geometry math questions. The way that you do it is that you'd have a training data set, right? Instead of training the entire model over, which would take maybe days on some GPUs, you can go on Azure and turn that training data set into a LoRa adapter, which is just a low rank adaptation adapter, which just means that it's a really small file that you can just attach onto the AI, and it gets good at that particular task. But you can't have multiple LoRa adapters on the same AI, I don't believe, right? But you could easily switch them out. So LoRa, for example, PySilica is, I think, 4 gigabytes in total. If you're supposed to retrain it, maybe it will become 6 gigabytes. But adding a LoRa adapter is just like 4 gigabytes plus maybe like 200 megabytes. So then the entire point is that you basically train the AI to be really good at one particular thing without needing the time and the resource necessary. Because training LoRa adapter, in my case, I think took maybe 2 hours in total. So it's just really quick comparatively.
Would it be reductive to say it's fine tuning, or it's a different approach?
I think they use the word fine tuning,
Okay.
but I can't be exactly sure, because I remember it's really brand new. So a lot of terminology is just like it's getting blurred between other AI methodologies.
Exactly. We were, but what you describe is the same process that I did to train my GPT-5, using a file of JSONs and taking an hour for it to change the weights and produce what are expected results. So that makes sense. So how do you see the evolution of AI on edge devices like OEM, Copilot, PCs changing the next generation computing? Well, this is good, interesting.
So I see 2 things. The first thing is that AI is getting bigger, which is funny, but also AI getting smaller. So if you have like an average, like they're trying to get him as big as possible, because then they should in theory be better at their job. They're gonna know more stuff. They're trying to get um um general artificial intelligence. However, simultaneously, they're realizing that doing that requires these massive server farms and all that kind of stuff, and require companies to be involved. So a lot of people are also looking to make small language models, one that run on phones. For example, I have a Samsung device, and they have Samsung AI, meaning that they don't Galaxy AI, which means they don't need to use the internet, but they would prefer to, because it's the speed. So my expectation is that AIs are going to get a lot bigger, but that's going to be the ones that you use online. And then every computer is going to have a really small AI that might not be good at everything, but really good at one thing. And I think the way that they're going to do that is using LoRa adapters. So because LoRa adapters allow like one specific skill, they might have like maybe 50 LoRa adapters on your computer, which in total would be like 1 gigabyte. And then swapping them out with the small language model to get it to do things better without needing to train the model to be good at everything. Because remember, the LoRa adapters can just be swapped in and out. And then simultaneously, I was reading this article recently, and it's focusing on it's the people involved are from Georgia Tech, and they're
Mhm.
talking about how the fact that small language models are the future, and that they're doing all these things to benchmark it, and that the only one of the limitations of benchmarks currently is that they are prioritizing large language models. So, for example, when they're testing small language models and figuring out is the small language model good, they're using the same metrics as if they were doing for large language models, which is kind of biased in general.
Right.
And then another article was mentioning that robotics needs AI is involved. And if you're a robot using AI, you probably want it on the device, like on the robot itself, instead of connecting to the internet.
Mm.
And simultaneously, that same sentiment can be like, if that's the case, then what is AI going to be useful for? How is it going to connect? How small does it need to be on the device, on the robot? And if the robot is, for example, locomotion, it needs to be
Mm.
really fast, so it needs to be super small.
Right.
So I think in the future, every single engineer, scientist, researcher is going to be focusing on trying to minimize the model without sacrificing the ability that they're moving away from. So, for example, Physica being not as accurate as GPT-5, for example,
Mhm.
then they probably are trying to get it more accurate by maybe adding just a few more parameters without getting to all the way up to the amount that large language models have.
Oh, that's very interesting, Orville. Yeah, it's looking like efficiency. It's like looking at a GPT, mini GPT that's faster with cheaper output. So that makes sense. Yeah. Wow. Wow.
Yeah.
So moving on to leadership coaching and STEM advocacy, you mentioned expanding access to robotics in underserved communities. What barriers do you see, and how are you helping to remove them?
So one of the major barriers is access to the opportunities, like I said. So just that being, for example, the national robotics team that I'm coaching, the way that it
Mm.
works is that we send out an invitation to every single school across the island to
Mhm.
nominate two students. And those
Mm.
students don't have to be involved in robotics at all. They just have to care about STEM itself. So that way we get around maybe 45 students per year to join the program, and we
Mm.
coach them to learn these new skills involved in STEM and robotics. And then after that, their job is to go back to their high school team and improve it. And if they don't have a high school team, because a lot of students that come here don't, then they can start their own robotics team. So
Mm.
then this is this like regenerative process where we accept students who don't have teams, they go back, form a team, and then now we are accepting students from this brand new team. We send them back, and then they improve their high school team again, because
Mm.
not every high school has coaches that can help them with robotics in general.
Mm.
So with all that being said, the way that I keep doing this is just by offering opportunities, helping students get involved. If there is an event that is gonna happen involving STEM, I'm gonna send it out to as many people as possible.
Mm.
Talk to the first tech challenge community, that's the robotics community here in Jamaica, and get them to tell other students, hey, you should be involved in it. So the entire point is that I feel like the moment that a student gets the opportunity to do something, they'll do it really well.
Wow. Man, Orville, you do everything. How do you balance academic excellence, technical work, and mentoring others like a full time job, man?
It is tiring. However, it seems like it's necessary. It
Mm.
is if I got a lot of help. For example, the reason I was in robotics is because I had great mentors. I
Mm.
had great coaches. There's probably students out there who exit robotics simply because they don't have that. So
Right.
then, can you get them to stay? Can you get them to be involved in it? And then, so the way that I really manage the time is by splitting. Oftentimes I split things into need to do and want to do. Need
Mm.
to do is I need to pass my classes.
Of
That is
course.
non-negotiable. I want to spend no more than the amount of years at my university that I need to. But then the want to do's are like, oh, I want to be a speaker at this particular school. I
Mm.
probably can't do that at a time, like in October. Like, for example, it's in October, so I can't do that because I'm busy with something else. I'm going to tell one of my friends that are super involved in robotics, hey, would you like to speak at this person's school? And again, I don't need to do that. I can get other people to be involved, and they will do that because they care about the same mission that I do. They have the same end goal, which is involving more people in STEM. So
Hmm.
that way, I don't need to do everything. I just need to get everything done.
Okay, that makes sense. That makes sense.
Hmm.
And it's not only you, but I'm sure that there's a ecosystem in the Caribbean that does that. I met your friends Kai and the rest of your team, so they
Yeah.
have that same goal in mind, right? To push each other to be better and also spread it around. I think that's occurring not only in Korea but other
Hmm.
parts of the world.
Yeah. For example, later down in the month, there's gonna be a panel discussion to
Mm,
get more students, university students here in Jamaica,
mm,
aware of Microsoft opportunities, because Microsoft is one of the only companies that is accepting students from the Caribbean to
mm,
do some internships.
mm,
So that kind of coverage needs to be made to these students. They need to know about it.
mm,
And similarly, the same partnership happens in Barbados, because I believe in Barbados they're currently doing something to let everyone know that, hey, you can also apply. It's not a Jamaican only thing. This is a Caribbean wide initiative, stuff like
mm.
that.
Right. Yes, yes, opportunities, studies. Now I'm going to hit you with a hard question.
Uh-huh.
The landscape has changed very rapidly the last 8 months. Um, what do you see opportunities coming now, and would that motivate you more to succeed or move forward, or what are your goals in the coming 5 or 10 years?
Okay, so um I definitely want to work in software engineering.
Mm,
I definitely plan to continue being a STEM equity advocate,
mm,
probably being the coach for the national robotics team. I have some plans of doing a higher education, not something that is like the current major goal, but something that needs to be taken into consideration, because if I want to work in robotics specifically rather than just software engineering, you have to have a PhD
mm,
or at least a master's, or do a lot of internships between that with robotics.
mm,
So the way that I plan on doing this is within the next 5 to 10 years, I'll be very involved in getting more students to apply to these kinds of programs,
mm,
getting into these programs, advocating for them, and then also take into consideration the fact that I want to develop in my career, specifically in software engineering and robotics engineering,
mm.
and keeping the same mission and goals that I have, maybe just on a larger scale. For example, if I'm not in Jamaica, I would probably still be involved in advocates for Jamaica and the wider Caribbean.
Mm. Yeah, that's amazing, man. You not only stay at the bar, you lift it up. So that congratulations, man. And thank you so much for being part of Orlando Insights podcast. Orville, it's great to see you again as well. We'll love to see you come back and see how what you've accomplished, what you developed, and what you've done so far. So very happy that everything's going well for you over there.
Thank you, Henry. It was so great to see you again. I can't wait to see you in Redmond, all that kind of stuff. It
Mm.
was great being on the podcast.
Thank you so much. That was Orville. If you would like to catch more insights from people like Orville or other professionals, please subscribe on our YouTube and Spotify. And Orville, do you have any social medias where they can reach out to you?
I would say you can easily reach out to me on LinkedIn. That's Orville Daily. You'll see my picture. You'll see STEM advocate, Microsoft
Hmm.
intern, that kind of stuff. Yeah.
Perfect. Yeah, when your information will be part of the link, so no worries. All right, everybody. You have a good night. Take care.
Okay.